Hey guys, how's it going? Sorry for this being late. I'm obviously a little sick. It's just life's happening, but things are going good. I wanted to, for our technical information, talk a little bit about testing. There is a lot of different types of testing, a lot of different ways to verify strength of materials, concrete, steel, piering systems, underpinning systems, polymer, etc., 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 right? There's a ton of different ways to do it. And the problem was first introduced to me actually when we used to do a push piering system, which didn't technically have an acceptance criteria. I'm already throwing words out there. So basically, testing. This is going to become important later, especially as we start talking about liquefaction mitigation, which should start next week, just so you know. In any case, the testing is very important. So what is testing? Testing, usually you want to develop something called an evaluation service report. Evaluation service report, or an ESR. And what these service reports are is basically like an independent third-party testing agency and or engineering firm or something else like that will evaluate a product and write up a report that gives specific design parameters or strength of materials or something else like that. So you can take that information into like City Hall and give it to them, and they would understand that this product's been tested in some way or another, right? Where that testing starts to get slightly loose is, again, the first time I was exposed to it was the push piering system. And what you had was a lot of manufacturers out there, and I'm not going to throw any names out or whatever, but a lot of people were saying like their weakest piers could support 100,000 pounds, which was great, but it was based off of like, if I had my L bracket, right, and then I've got my tube that comes here, they would shear the tube here, put the testing apparatus right here, like maybe an inch of space there, and then apply the load directly down, where you've got a ton of support, right? You've got a ton of support there. But when you take a look at like the 10 foot of unrestrained fill, you look at the AC358 for helical piles, which is what people use for push piers now, you've got more like 10 feet. Now you have to worry about like the flexion of this, you got to worry about the ultimate bracket capacity based off of however this is designed, you've got to worry about a whole bunch of other stuff, right? So you can see just that's one very simple, one very common, or I guess beginning thing. That's not so much of a problem now. Most of the piering manufacturers are pretty good about the testing as far as push piers go now. I know PEI made a great one for Safe Base. Few different ones are approved through LA at this point. Like things are pretty good as far as like the piering systems goes. But I lost my. Sorry. But you will also have to note that, and you get like a PEI report or something like that, they're going to specify that your push piers handle only axial compressive loads. Only axial, up and down, compressive, down loads. So your push pier is not designed to resist any lateral stability, anything else like that, right? It's good if you have testing also on each individual section, because each section has a certain amount of flexion, certain amount of strength. I told you about that weird project where we pushed a pier 200 feet deep before we figured out it was actually coming up in the neighbor's backyard, right? That happens when steel bends. So if steel bends, it has to have some amount of bending or some flexion that it's got. So there's been some projects where we've had to push piers down and then fill it with concrete in order to increase the rigidity of the steel. That's based off of the testing that was done, right? So testing becomes very, very, very important. Now I've mentioned a couple times AC358, AC being acceptance criteria, right? So this is done for helical piles, helical piers, acceptance criteria, AC, right? 358. So that's for helical piles. And what an acceptance criteria is, it's done through the ICC, which is the International Code Council. International Code Council. It's done through the ICC. These are probably the biggest guys in the game when it comes to developing like evaluation service reports. They even have an ICC-ESR. ICC-ESR. Hey. So what this is a group of people who come together and they're experts in the trade, all the different trades, and they regularly check, double check, and update. They have meetings and update sort of what the acceptance criteria or ensuring that products and services and things are in compliance with applicable building codes. Most of the time, you can take an ICC ESR into a building department and hand it to a plan checker, and the plan checker is already going to understand that the proposal that you're issuing, as far as testing, strength of material, calc design, and all that fun stuff, as long as your calcs are like in compliance with the spacing and the post and beam or whatever, and you have this ICC ESR, they're pretty much probably going to give you a permit. Like some questions had, right? If you're using a push pier for lateral support, which you're not supposed to, then still they won't. But if you're using a push pier for axial compression loading and your calcs substantiate everything from your ESR, more than likely you're going to get a permit. Okay, so the ICC is a really, really huge one. And they developed the acceptance criteria 358 for helical piles. So what an acceptance criteria is a group of people who came together, had a discussion, did some research, and then said, all right, we're going to do standardized testing with standardized procedures using standardized equipment in order to determine what the strength of materials and blah, 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 and blah, 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 and blah, blah, blah are, right? So instead of somebody using the first test that I told you, testing right here, right? Everybody has to test in accordance to that, right? And if you can standardize the testing, then you can standardize the output. You can test, if you can test everyone in accordance to all of the same things, then you can figure out what the actual strengths of materials are based off of a single unit or a single test, right? So acceptance criteria became very, very important. Again, ICC sort of spearheaded that. They're kind of the biggest names in the game. Then you have like IAPMO, and you have PEI was another one. And then, I mean, drilling down, right, you've got the IBC, the International Build Council, International Building Code, got it. Then you have your state codes, CBC, California Building Code, because I'm in California. And then you move down to, you even have like municipal codes. Each different city has their own codes. And then you have like San Francisco or LA, which are super special. They have their own LA building code. And this is more like county. So people like LA will require an ESR, but they won't accept an ICC. What they'll do is they'll take in your ICC report or your IAPMO or PEI or whatever. They'll do their own evaluation on it in accordance to their building code, right? Make amendments and then hand things down, do whatever, and then they will give you an LA research report, right? And this research report does what your ICC ESR does for like the rest of the country. Right? So something like LA, the reason why I talk about LA a lot is because if you can get an LARR, I mean, I've used the LA research report in Flint, Michigan when I was helping a friend pull permits for a foundation repair for their house, like years and years and years ago, right? So, I mean, it's got weight. The important thing is standardized testing. LA, like when the polymer was going through getting its LA research report, we couldn't use just any testing agency. We had to use not just any ASTM testing, which is, you know, standard testing of American standard testing of materials. We couldn't just use any of them. We had to specify, we had to use specific ones of these, right? And then we had to use specific agencies, which are approved only through the County of LA, which I think for the polymer they used Smith Emery, right? And that's how they developed their LARR through everything. So testing is really, really important. Once again, this is just something I wanted to get a little more technical into. Something I wanted to introduce to you guys to become much, much more important when we start discussing liquefaction mitigation, which once again should start a little more next week. Thank you guys so much. If you have questions, comments, concerns, drop a comment below or message me directly. Please like, share, subscribe, and all the jazz. Thank you.